Welcome to GDP's Physics and Simulation 2. My name is Felipe Bellini, and this is a video demonstration for Project 2, addressing the lectures by James Lucas at Fanshawe College. Project 2 is about physics decoupling and collision detection between planes and spheres. Because this project requires the coupling of assemblies in our game engine, let's start taking a look at the engine architecture and its different projects. Here is the solution layout. For Project 2, the most important parts of the engine are the interfaces and the physics libraries. When the game starts loading systems, it can select different physics wrappers without changing the game itself, but only the physics behaviors inside them. This means that in Project 2, we should be able to switch between the physics bullet DLL and the physics custom DLL. Bell Engine is based on the ECS model. Currently, there are 8 systems in the engine. Each has its own update function. The world will call these update functions for each scene in the level. Here's an example of the decoupled physics system. Everything starts at the interface library, where we can locate the iSystem, iSystem Physics, iRigidBody, and iCollider interfaces. Each physics assembly inherits from these interfaces and creates implementations and wrappers for these objects separately and internally. Since the game only interacts with the update method of the iSystem physics, it has no knowledge of the actual physics that's running in the game. Each physics update performs the integration, collision check, and collision response for all rigid bodies in the game. The next slide shows a representation of a level. A level is an XML file describing all objects and scenes in the game. A scene contains a camera, in addition to their own game objects, lights, animations, sounds, etc. A scene may be drawn to the screen or to an external frame buffer or a texture. Now, let's take a look at our game on top of our custom engine. Notice that the command line outputs which DLLs are currently in use by the game. Using our free camera, we can fly and move smoothly using the WASD keys in our 3D space. Collisions are happening between spheres and planes, and spheres and spheres. This is the debug rendering mode. You can see the lines at the center of the sphere and the shapes drawn around the planes, so you can know exactly how large is each plane. Just press F1 and select toggle colliders for that. Then F1 back to the game. There are 2 ways we can interact with the spheres in the game. We can approach a sphere and grab it with the mouse click. Notice how the sphere changed its color to red because it's selected. After grabbing a sphere, you can either let go of the sphere by pressing the right button, or you can just press spacebar to launch the sphere towards whatever you're looking at. We can see that the spheres are colliding against each other. So I'm picking a small sphere here and shooting towards. Notice how the yellow sphere bounced on the red sphere, which is bigger sphere. The other way to interact with spheres is by pressing F1, moving the keyboard controls instead of the camera to the game objects, then going here in Scene, select Scene 1, select Game Object, and select whatever game object is in the game. Let's play around with the debug ball 0, which is the ball at the center of the plane. It just turned red. If I press F1 again to go back to the game, I should be able to move the ball on the XZ plane using the WASD keys. Here am I pressing D, W, A, and S. So every time you press one of these keys, it applies 1 unity of force in the axis it's supposed to move. That concludes the presentation for Project 2. For more information, visit Fanshawe College, contact Felipe Bellini or James Lucas at Fanshawe College. Thank you.